Okay, I'll give some solutions to the exercise on variance estimation for systematic designs. The solutions are available as a PDF on the website as always, but I'm going to show you going through them, at least the first project in the distance software, just to give you another view of that. So let me switch to the distance software here. I'm also going to turn my camera off because I'll need the whole screen. There. Okay, so the first thing we asked you to do was to open up the project Systematic Variance 2. So if I do open project, it's available as a zip file. And if I go down there, it is. Okay, it wants to unpack it, and the exercises folder is fine. There we go. And then the next thing we asked you to do was create a new analysis, which we're to call without post-stratification. There it is. Let me just slide the slider along a little bit here. There. And we want to create a new model definition for it. So if I open up the analysis details here, there we go, and a new model definition, which I'll call without post-stratification. And we want to set no adjustment terms in the detection function adjustment terms, manually select none, and also in the constraints button, no constraints. Well, if there are no adjustment terms, then you don't really need that, but that should speed things up a bit. And then in the variance tab, that's just so that we're fitting just a half normal to these data. That should just speed up the bootstrap that we're about to do. So we want to select a non-parametric bootstrap, and 999 ought to be OK. So if I just click OK and then click Run, we should see along the top here, it's running the analysis, and there's the bootstrap progress. 26%, 42, 50, 58, 65, and 100, it's finished. OK, so what we're particularly interested in here is the variance on the, if I just ignore all the detection function fitting, the variance on the density estimate, which is given here, is 27.7%. Oh, and so that's the analytic variance, and if I look down a little bit further, I can see that the encounter rate is 95% of that total variance, and 4.3% of it comes from estimating the detection probability. I can also look at the encounter rate variance itself, which says a CV of 27%. So when we look at the overall CV, 27.7%, and the encounter rate CV is 27.1%, you can see that the encounter rate CV accounts for almost all of the overall variation. And then lastly, if I look right down at the bottom here, there's a bunch of bootstrap summary. So the bootstrap encounter rate CV from the bootstrap is also 27%. That's from estimating the detection function 5%, and the overall CV is 28% from the bootstrap, so quite similar to the analytic estimate. Now remember that this is quite a large overestimate, because this is a case where, well, we're assuming that the lines were laid at random. The lines were actually laid according to a systematic design, and we have the case where line length varies and density varies across the study area. So the next thing that we asked you to do was to try these post-stratification variance estimators. So if I just shut this, I'll create a project, another analysis, the new analysis button here, and we were to call this one post-stratified, no adjustments, no bootstrap. Post-stratified, no adjustments, no bootstrap. And so I need to create a model definition to go with that. So a new model definition, which I can call post-stratified. Let's call it no adjustments, no bootstrap. So instead of, we want to turn the bootstrap off here, and we want to click on the Advanced tab for estimating the encounter rate variance, and choose the post-stratify option grouping adjacent pairs of samplers. I'll do the overlapping one in a minute. Okay, so if we press run here, and it's finished. If we look down at the variances, so the density estimates, there we go. So the coefficient of variation is now 8.64%. Remember last time it was 27%. And the encounter rate variance is down to 6.45%. Before, remember, it was about 27. If I go back and look at the contribution to the overall variance, 44% is from the detection probability, 55% from the encounter rate. The detection probability is exactly the same as before, it's just that the encounter rate variance is so much less now, it's making up a bigger proportion of the overall variance. So an absolutely enormous difference in variances. You can see that summarized here as well. This is the density coefficient of variation. It was 27% before, now it's 8.6%. Let's try the overlapping estimator. So if I create another analysis, and I'll call this one post-stratified overlapping, no adjustments, and I need to create a new model definition for it. So a new model definition, post-stratified overlapping. No adjustments. I'll go into the Advanced tab and I choose Post Stratify with Overlapping Strata and click OK and run this. Okay, in this case, so we had an 8.6% CV last time. This time it's 7.97, so almost the same as last time. So remember that the overlapping post-stratification is really just a more precise version of the initial non-overlapping post-stratification. So there's no reason to suppose that this estimator would be any less or any more. It's just more precise. Indeed, if we look at the encounter rate tab and we look at the degrees of freedom, the degrees of freedom here are 19. There are 20 lines in total, so there are 19 overlapping strata. If I go back to the post-stratified estimator that wasn't overlapping, and I find the same same page, there it is. The degrees of freedom in that case were 10 because we were only able to make 11, or is it 10, non-overlapping post strata. So in general, you should think about going for the overlapping one. You just get more strata that way, so you get a better estimate of the variance. And in this case, because we have a density gradient and a large variation in line lengths, we have an enormous difference in the estimated variance between the estimator here that assumes completely random lines and the estimators here that assume correctly, or that allow for the fact that correctly the survey was a stratified. The survey was a systematic survey. Okay, I won't go through the Systematic Variance 1 project, but what you should have found then is that it really doesn't make very much difference whether you do post-stratification or whether you don't do post-stratification, because in that case there wasn't a strong density gradient. For more details, please see the Solutions PDF.